Good morning, this is your maths for today. Carrying on with fractions. So yesterday you did multiplying fractions by integers or by whole numbers. Today we're doing fractions by other fractions. So we're going to start off with a couple of starter questions here, and then I'm going to take you through the presentation. We'll obviously be stopping at times for questions and times for you to try and answer them yourselves, so it might be a good idea to have a pencil and paper ready, and then we'll also go through the questions on your worksheet itself, just to try and clear up any confusion there. All right, so the first thing you want to try is, before we even start the presentation, have a go at the warm-up questions on page 1 of your J2 file. So you've got these 4 questions here. So pause the video now, have a try of those. It's just a recap of what you were doing yesterday. So pause it and have a go. All right. So if you're watching this, I'll assume that you've finished those 4 questions and you're ready to go through them. So a quarter times 3, so we do 1 times 3, and of course that is 3, and our quarters stays the same. We've got 3 quarters. As it's set, you can see here, 1, 2, 3 quarters. Right, 2/5 times 3, so 3 times 2 is 6, and we keep the fifths the same. 6/5 is improper, so we need to convert that, and that's going to be 1, remainder 1, 5th. Number 3, 4/9 times 6. Well, 4 times 6 is 24, staying in 9th. 24/9 is improper, so that becomes 2, because 24 divided by 9, of course, is 2, and a remainder of 6/9. We could end there, but 2 and 6/9, they are both in the 3 times table, so we could actually simplify that and say 2 and divide 6 and 9 by 3, and we're going to end up with 2/3 is another possibility. And number 4, so we've got a mixed number here, timesing by a whole number. So let's do the whole numbers first. So 2 times 3 is 6. So let's put that down here to keep that in mind for later. All right, now the 2/3 times 3. So 2 times 3 is also 6. So I've got 6/3. That's an improper fraction. 6 divided by 3 is 2. So that's that bit done, but I've still got that 6 left over. It's now 6, add the 2. The final answer on that one is 8. So we did all right on those. Okay, we'll come back to the worksheet in a moment. Let's have a look at your presentation for today. We've done all these. All right. So what I'd like you to imagine first, so Sally eats half of a chocolate bar, and she then eats half of what's left. As a fraction, how much of that chocolate bar is left? That's our question. So Sally eats half of the chocolate bar. Let's go through. Okay. And she's then going to eat half of what's left. So what fraction is left? Now, we can't just simply say, well, it's not a half, and it's very difficult to say because obviously all of these, what you can see now, all these fractions are different sizes. Obviously, this is different to these. So this doesn't help. So if we imagine, though, that other half was also cut into quarters, because it's then everything is the same size, then it becomes more obvious and more clear to be able to see that, of course, what we're actually doing is, what we find then is a quarter is what's left. So let's go through what we did there. So what we found was half of 1. So she'd eaten half. Remember, Sally had eaten half. So half of 1 was half. But then what we had to do was actually find half of half. So that's actually what we're doing today, a fraction multiplied by another fraction. What I'd like you to bear in mind for the rest of this lesson, and, well, forever really, is that multiplying, another phrase for it can be of. What's half of half? So we make the other side look the same. So we've got equal, we need to have that equal sized pieces. And we end up in this case with 1 out of the 4 pieces being shaded. So that's why we're left with a quarter. So what we're doing now, basically, we're using our visualization to look at why this is true, and then when we'll get onto the arithmetic side of it later. So what I want to show you how to do that is with what's called an area model. Okay, so this is an area model here in front of us. So we want to see what a half of half looks like. So across one of the sides, I'm going to divide that whole square into half. And then I'm going to divide it into halves on the other side as well. Now I'm hoping that that will make it a lot clearer for you when we say what's half of half. So we had the whole piece. Let's just go back. So we had the whole piece. We cut it in half. We've got our halves, but then we cut those in half as well. And what is 1/2 of half? That's this area here, using the arrows to help us as well. Now we've got one piece shaded out of 4 possible pieces. 1, 2, 3, 4 pieces, but only one is shaded. So this means we've got half of half is a quarter. Let's have another look again using an area model to help us solve these. So we've got a quarter of a third. So we're going to divide one side into quarters. And keep an eye on that blue arrow. That's the area that we want. We only want 1/4. So that bit's been split into quarters. So I'm hoping you can already, thinking of the last one, along this side, down the side, I'm going to split it also into thirds along the other way. Now, how many pieces do we have in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. And we want to know what 1/3 of the quarter was. So here's our 1/3 and here's our 1/4 piece that we're going to shade. So what we've been shaded is 1 of the 12ths. So that's our answer. Now, for those of you that realize your times tables and remember your times tables well and can spot them when we're doing things like fractions, you may have already spotted the arithmetic side of this. So on your piece of paper, if you've got a piece of paper in front of you, have a try at the area model version first. Again, obviously this is not what you'd use to solve the problems when they're presented to you, but it is a way of understanding why what you're doing is correct. Okay, so we're visualizing it. So on a piece of paper now, try and have a go at creating your own area models for these two. Also, there are a couple of questions when you do your actual worksheet that are very similar to this, so it would be a lot more helpful to have a try now. So on your piece of paper, let's try this one first on the left. So you need one way, it's going to be divided into halves, and another way divided into fifths. Okay, so I'm going to pause the video now, and I'd like you to have a try. All right, so if you're watching now, then let's carry on. So you had half times a fifth. So we split it into halves along the top, may as well, and fifths down the side. And then if one is shaded, we've now got 1 out of 10 has been shaded. So we've got 1/10 shaded. The other one, same thing. So let's split it into thirds across the top and fifths down the side. When one of them is shaded, you've now got 1 out of 15 pieces has been shaded. One more. Pretty much the same deal, but I'm going to stop talking for a second and give you a chance to try and figure this one out for yourselves. So if you were thinking ahead, try and think ahead now, even while I'm talking, and just think, so if the top side is going to be divided into thirds, but we've not got unit fractions here. We don't have 1/5 and 1/3. I've got 4/5 and 2/3. So how much of it is going to be shaded? Okay, let's start to see. So split the side into fifths. Remember, we wanted 4 of those fifths is what's going to matter to us. That's why this arrow has come in. So these 4 lines are going to matter to us. I'm going to split the top into thirds. So let's put those lines in. And remember, 2 thirds is what we want. So these 2 lines are what's going to matter to us. So here's our 2 thirds. So it's everything in this section here is what's going to matter to us. There we go. And now how many are shaded? 1, 2, 3, 4, 5, 6, 7, 8 out of 15. So 8/15 is the answer. So 4/5 times 2/3 is 8/15. And as I've said, some of you have probably started to realize the arithmetic side of how these can be done. 5 times 3 is 15. 4 times 2 is 8. All right, let's have a look at questions 1 to 3 on your worksheet together. All right, so question 1 is, in your own words, explain why a half times a third using that grid method or the area model, how that represents a sixth. So basically, pretend you were talking to a year 4 child. How would you just write a couple of sentences on these 2 lines here to explain? Number 2, shade the diagram to show the fraction multiplications. Complete the multiplication. So you've got a half times a quarter. So when it comes to this, what I would recommend doing, use this to make it more transparent. You're going to shade in like that, shade in a little bit of that to show a half and a quarter, and then how much has been actually shaded out of how many. Bear in mind, of course, now you've not, the denominator is essentially changed by how many squares you've got. B is very similar, so use the area model to help. So a half times 2/3. And then question 3, a bit like you were hopefully doing on paper just now, divide the square into 2/3 and 3/4 to show that it's equal to 6/12. So they've already told you the answer, that you should, if you've done it right, you should end up with 6/12. So what you should be doing, of course, would be dividing it into 3 equal parts, perhaps down this side. What would probably be a lot better is actually if we use the straight line tool. Now, I understand, obviously, you're doing it on computer. It's not going to be perfectly equal, but as long as it's as equal as can be. Now, that's the thirds down one side, so remember, you've got to do quarters on the other side. You could have done it the other way around if you prefer. You should ultimately come to the same one. So what I want to see as a final answer from that is a finished area model, and of course, please shade it in to show that you've got 6/12. All right, so I'm going to pause the video now. I think you should do the same, and then go back, answer questions 1 to 3, and then when you finish questions 1 to 3, unpause the video, and then we'll carry on with the presentation to show you how to do this. Okay, if you're watching this, then we're carrying on now from, you've finished questions 1 to 3, and we're going to carry on. So what did you notice? Well, we briefly talked about this. So you've probably spotted that 5 times 3 is 15 and 4 times 2 is 8. So this is a way, so the area models we were looking at, all they were really, as I say, is a way of proving why 4/5 times 2/3 is 8/15. So if someone said that they wanted you to prove it, that is how you could prove it. So I'll let you try these. I'm going to stop talking for a second. I'd like you to use that same method. 2/7 times 4/5. What would be the answer? 3/8 times 2/5. What would be the answer? Again, always be on the lookout, though, before you do these. Is there an opportunity to, is it improper? Do you need to put it back to mixed number? Can you simplify it? Okay, let's have a look. So 2/7 times 4/5. So 2 times 4 is, and 7 times 5 is, so 2 times 4 is 8, and 7 times 5 is 35, 8/35. Nothing we can do with those. They're not in the same times tables. That's as far as that one goes. 3 times 2 and 8 times 5. So 3 times 2 is 6, and 8 times 5 is 40. Now, both of those numbers are even, so is it possible that we can simplify them? If we halve them, we get 3/20. 3/20, can we go any further? No. Okay, so that method is pretty much going to get you through the majority of what is to come. So just simply times your numerator by your numerator, times your denominator by your denominator. So if you're stuck on any of the questions, really, you can come back to that. I'm going to go through one problem now. So some halves times some fifths equals a fifth. Okay, so let's use our area model to see if we can solve it. So let's split into halves and fifths. If we split into halves and fifths, what should the denominator be? Tenths. But remember, 1/5, if we're going to put that into tenths, then the fifths need to become tenths. So we're timesing it by 2. Well, then that means that 1 needs to get multiplied by 2 as well. So it becomes 2/10. So we need to make some halves times some fifths to become 2/10. Well, 2 times 5 is 10. So that's our denominator side, correct? We need something times something is 2. Well, how about 1/2 and 2/5? So 1 times 2 is 2. Just the same as it is would be that way around as well. There you go. So that's your problem. That's going to help you a little bit with the mixed number questions. Beg your pardon, missing number questions when you come to them. So let's have a look from question 4, just a couple of examples of each to get you started. Get this on again. There we go. All right, so let's do 4A. I'll do this in red, actually. So a quarter times a fifth. So 4 times 5 is 20, and 1 times 1 is still 1. So that's as far as that goes. It can't be simplified any more than that. Looking at D, let's have a quick look at this one. I won't leave this one here for you. You can try this yourself. But this is basically this exactly as it looks. So an eighth times a ninth times a tenth. So what's 8 times 9? And then when you get that answer, times it by 10. And then that will be your denominator. 1 times 1 times 1 is still 1. Questions like C, it's just the other way around. So it's still what's 7 times 8 and 1 times 1, and the answer goes into the box. And I believe that should help you through the rest of question 4 and 5. Just as it says there with the hint, be on the lookout. Are there any opportunities to simplify your answer? Always be on the lookout for a moment where it needs simplifying or turning back into mixed number. So you've got some missing number problems here for question 6. So a tenth is the same as half times a what? I think we just did that one, you might remember, with the area model. And then we've got this one, 1/5 times some thirds becomes 2/15. So you can try and solve that one. With question 7, what you might want to just think about is that it's possible that the answer has already been simplified, as you can see here. So we're trying to put the answer in tenths, but 4 times 5, well, that's not 10. 4 times 5 is 20, but 20 is double 10. So that's my clue for you. So that answer 1/10, that's probably been simplified. So if 20 has been halved to make 10, well then 1 must have been halved as well. And I'll say no more. Your last question is question 8. This is exactly the same method. Again, since we use the area model, it's basically the same thing when you're working out the area of squares and rectangles. So 4/5 times 2/3, 9/10 times 9/10, using the exact same method you were using before. And there's a challenge question here, which I'd certainly like you to be trying, especially as that's going to come in handy in coming lessons. Okay, I think that is everything you need to know. Of course, don't forget to save your work. Any problems, use the J2 message, and we will speak to you then. All right, guys, take care of yourselves. All the best.